Today is May 30, 2025. I will talk about a link layer first. So link layer, MAC, MAC protocol come out. So there you saw how floated ALOHA can work. So floated ALOHA's point is maximize 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 throughput. Maximize throughput. Throughput is which is what, bit per second, right? Bit per throughput. How can you fend well with each of the node? So this idea was about random access. It's not about like TDMA, like you split the time. It's not you split the bandwidth, which is time or frequency, or there is also code cDMA. We will talk it later, but it's just random. ALOHA is just random accessing. Basically, what they do is random access. So it will well work when everybody just not really send much data. So ALOHA's efficiency is 37%. You can calculate it by probability of success by given node, which is same as node transmission probability. You can calculate it by probability or success rate and also each other node together, and you will differentiate it. And for Ethernet, how to block collision, they also have binary exponential backoff. So if something is blocked, then they will make a number twice larger. So it's binary collision. And for APR, for even they know how when others are sending the data, there can be still collision happen, CSMA collision situation, which is because there's time difference each other. So MAC protocol and ARP protocol is in same LAN situation, but there will be MAC address. So if you see here, from A to B in same LAN, this will be switch and this will be router. Then in this situation, DHCP is what give A its config IP and gateway. Subnet is tell A to forward to router, and ARP is which is A learns R's MAC address. And Ethernet frame is carries IP datagram to R, and routing is what router does, which is R check forwarding table to this site interface, and NAT is R maybe rewrites IP port, IPv6 and IPv4 changes can affect to tunneling, and SDN is which is central controller gives router its rules, and open flow is matches multiple fields, not just IP. Then fragmentation and TTL is about IP layer per host operation. So from datagram, IP datagram and MAC frame, they know its IP address and first hop router and else MAC address, how they go. From this MAC source and destination and source IP source and destination, they go like this. And R forwards datagram with IP source A, destination B. R creates link layer from frame with B's MAC address as destination address. Frame contains A to B IP datagram. And R forwards datagram with IP source A, destination B. R creates the link layer frame with B's MAC address as destination frame contain. So if we see this, then first A wants to send datagram B, then there is IP layer and MAC layer, then I send ARP request and A sends frame to R, then R receives frame, and R sends data B. What was related was chapter 4. Uh, what router do is destination-based forwarding, and there can be buffering, IP datagram format, and DHCP client, IP address NAT, IPv6 tunneling, and SDN open flow. When you do open flow, there is destination-based forwarding, has link layer, network layer, transport layer, and open flow. Example, if you see this, then there's IP source and destination, so they forward. In this case, this X, do you know what is this X is? Uh, this X, this is router or
Yeah.
switch. It's router.
It's a router, yeah.
Router. Is this different thing with what we learned?
Yeah. So OpenFlow is SDN routing, right?
This is the same with this router. Router here.
Um,
Here, this is also router.
what chapter was it?
It was chapter 4.
Yeah, so then it's basically the same.
Same. But what we've seen today was only in the same LAN situation, more specific.
Yeah, so this is like actual routing.
Actual routing.
And
Okay.
today we learned about forwarding.
Forwarding.
Yeah, without IP addresses at all, because this is with IP addresses.
Okay, thank you. So how addressing looks like is routing to another LAN, and forwarding table is about routing. And for forwarding, there's Ethernet framework, which is programmable data address, source address type data, and CRC, which is error correction, error correction. And Ethernet switches to self-learning when they do forwarding. To self-learn. And so switches and router difference, if you see this, router is network layer, switch is link layer, and router computes table using routing algorithm IP address, switch to learn forwarding table using flooding learning MAC address. So if we see all the things together, then what happens is basically first DHCP. By using DHCP, owner will get IP address and DNS server, and DHCP will request encapsulated in UDP, and it will broadcast it, demux it. Then it will, before sending HTTP request, it will get DNS. DNS will query created, and to send frame to router, what we need is ARP, MAC address for router interface, and ARP query, broadcast received by router, which replies with ARP reply giving MAC address. And then IP datagram forwarded from campus network will do routed, and table creates by RIP, OSPF, and or BGP to DNS server, and TCP connection. After that TCP connection, a TCP socket and TCP SYN segment is doing transport layer level connection. This is what we summarize. So getting IP via DHCP, and DHCP will get ACK, then ARP for router MAC address, and DNS query to clients sends a DNS query to refer google.com. Then the topic, what it comes out is BGP and things, and TCP handshake. We will finally do this, then we can check it through Wireshark. How this is DHCP and looks like. And also this is link layer topic. In chapter 4, we talk about when buffer happen. And for chapter 7, it's also huge topic because wireless situation, dynamic modulation come out, which is physics of bit. BER and SNR is key pointing. SNR is signal to noise ratio, and BER is bit error ratio. So if SNR is higher, then bit ER is lower. And in each of things, it is affected by dynamic modulation. Our laptop is doing dynamic modulation, so it it can, this is the very basic thing which can represent bit as sinusoidal wave function, and it can go complicated. So yeah, now we use 4 angle to represent 2-bit, and you can go more complex to use 8 angle to get more bit. So this is how modulation works. And what I told you before, there is cDMA, one of the division method, not using whole bandwidth, but using code, different code with orthogonal code. This is made by co-founder of Qualcomm. Thank you.